Hello everyone, my name is Ranak. Today's topic is installing Marlin on our Ender 3. Marlin 2.0 is out, but reason for not installing that is that uh, it consumes more space, and on Ender 3 the stock uh, processor that we have is Creality 1.1.4, that is 8-bit, and it has only 128 KB memory, which is very small. And if we use Marlin 2.0, many features will have to disable. So Marlin 1.1.9 version best suits where we can enable few features like mesh bed leveling, thermal runaway protection, and uh, even continue to have this power loss recovery that comes with the stock printer firmware. What tools we will require for this is at Mega USB ASP. You can use any other brand USB ASP. So we need to convert the 10 pin to 6 pin. So for that we need an adapter, then internet connection to download the firmware and some of the drivers and tools. And on the tools we need Arduino IDE, then Zadig driver tool which helps us to install the driver for the USB ASP and few other. So step one is to connect the USB ASP to the USB port of your computer, and using the Zadig tool, install the driver. So let's do that. I have already downloaded this tool. Yeah. So from options, list all devices, and you have this USB ASP. Just reinstall this driver. It says driver got installed successfully, and here you can see that we have this USB ASP available. Next step is that we need to connect the 10 pin to 6 pin adapter to the USB, and then the 6 pin side female port needs to be added to the 6 pins in the Creality board ISP port. So where is this? So here next to the LCD display connector you have this ISP. If the connection is done properly, you would see that the board has lit up. And if the LCD display cable is still connected, yeah, the LCD on the printer gets powered on. So now the next step is to download Arduino IDE. We go to this arduino.cc, and from there we download the Arduino IDE. We will go and download the Marlin source code from the GitHub. So we need to download this. So download this zip from the GitHub, and once the zip is downloaded, unzip it, and you would be able to get this folder. So inside this folder, open this Marlin examples, go to Creality Ender 3, and copy all these files and paste it inside the Marlin folder. Once you do that, search for this Marlin Arduino file and run that file. So it will open this Marlin, uh, all the files that we need to compile. So now the next step is to load the uh, board, Sanguino board. For that, uh, I have provided You go to boards manager, and then from there you download the Sanguino. You download this Sanguino, the latest version of Sanguino. Once that is done, you go into configurations.h and make the changes. So now we will have to go and edit to enable this thermal protection, mesh bed leveling, and because of the size limit we'll have to disable the arc support. This is rarely used, and with the Cura slicer we do not have that G2 and G3. We do not have that G2 or G3 code in our G code, so we don't use those commands. Then enable power loss recovery, and as a fun we will change the name of our printer. So go into configurations.h and scroll. So first of all we'll have to enable, there would be show boot screen. So if it is disabled, enable it. Then uh, there is the short, okay, show custom boot screen. So we don't want any custom boot screen. We'll disable that. Then there is this define custom machine name. So there we will give the name of our printer. Then scroll down and search for thermal, and here you would see thermal runaway protection. So if it is disabled, enable it. Then so what this thermal protection will do is, as you can see in the documentation, thermal protection provides additional protection to your printer from damage and fire. Marlin always includes safe mean and max temperature ranges which protect against a broken or disconnected that time the processor would avoid any further damage and stop the print. So this way any fire hazard can be avoided or damage to the printer board connection. So here we will enable mesh bed leveling. So mesh bed leveling is used to uh, generate the grid or manually, or it is used. So once we manually uh, do the bed leveling, sometimes the surface is not perfectly flat. So that time this grid manually, whenever this mesh leveling is used, we mark, the printer marks the different locations on the bed and stores that, and during the printing time it does a proper compensation for that. So we will enable this mesh bed leveling. So if it is uncommented, if it is commented, just uncomment. And when the mesh leveling is used, we need a feature on the control panel to help us in enable this restore leveling after G28. So what it does is, after G28 commands, the leveling is disabled on completion, and enable this option to have G28 restore the prior leveling state. So after completing the bed leveling, the the grid state is restored in the memory. H, we need the submenu for LCD mesh level building. So if it is uncommented, if it is commented, just uncomment it. So an option will appear in the prepare menu. Now we will go in configurations underscore adv, that is advanced configurations, and here we will disable arc support. So G2 or G3 command support. So we hardly it is used, so we will disable. We need to disable this feature because the amount of space that this program will, this firmware will consume over the printer's memory would exceed and it won't compile. So now in the tools, we go in the processor, select at mega 1284 16 megahertz. That is the processor on the Creality 1.1.4 version. That is the standard Melzi stock printer. And in the board, we would see this Sanguino AVR. So we will have to select the Sanguino board. Now we'll go and compile our changes, save all the changes, and then start compiling. So we see here that the compiling has done successfully, and our configuration or the firmware is taking 98% of the total memory available on the motherboard. So now everything is done. So we are ready to upload. So we'll upload this using the USB program. So we are not flashing the bootloader on the processor because we saw that the memory is very less, and adding the bootloader would consume some more memory, and the memory available to install this firmware would be reduced, and few more features we'll have to disable. So just to avoid that, we are using this approach, and thing is done. So your printer has been up, the firmware has been updated.